Doing data recomputations can be incredibly costly, not only from a compute standpoint, but also because it impacts your users. Like, if you're recomputing multiple terabytes or petabytes of data, it can take time, and your users are going to be seeing stale data until your recomputation finishes. So if you have a dataset with multiple terabytes of data in it, and you have 1 million new rows, why don't we just recompute the 1 million new rows? Like, the code didn't change, so we can avoid recomputing the whole historical pipeline. This will allow the computation to be done in seconds, bringing new data to your users. Let me show you how you can compute incremental transforms within Foundry. So let's create a dataset and upload some data that I have on an SCV file within my computer. For that, I just need to drag it into a new dataset within Foundry, confirm that I'm importing data in accordance with the policy of my stack, and hit upload. Once that file is uploaded, I can see the rows in the dataset on the interface. So now that you have some data within Foundry, let's also create a repository. Here I'm going to jump you right into the end of the process. You already have other videos showing this, so let's just create some code to add a process timestamp into our dataset so that we know when every build run. Here we can see it ran at 12:42. If we keep reheating build, it's just going to keep recomputing, and that timestamp is just going to keep incrementing to the last time I built. Here we can see that the build is at 1:46, and we can see in the process timestamp that it's 12:46 as well. Now we want to explain incremental, so let's go into it. You can start by searching on the docs for incremental, and it gives you a write-up of how it works. Technically, it's just an annotation that you can put into your transform that will detect if new transactions exist within your dataset and compute those. Transactions on themselves are the files that exist within your dataset. Here we can see that the SCV file we added already exists there, which represents those two columns. Now, if you keep updating the data with the file name being always the same, what you're doing is actually generating what we call an update transaction. And that update transaction just replaces the file. Every time a file is replaced, you're invalidating the incrementality for that file in itself, and you're going to ask for it to be recomputed. So here, because we updated the file with the same name, we're generating an update transaction, which once built is just going to rebuild the whole thing. You see there is no new file on the files. And if I hit build, our snapshot timestamp, in this case, our process timestamp, is just going to keep updating to the latest time. Here we can see again 1:59, 12:59, and we see on the process timestamp 12:59 as well. So let's create an actual new transaction. We can do that by creating a new file called transactions.scv2. In this case, let's add another row of data and save it with a different name, transactions2.scv. And again, just drag it to the interface and hit confirm. Like, there are other ways to ingest data into the platform, but here we're just showing it with drags. As you can see, we're generating an update transaction. Sorry, in this case, an append transaction, which shows up here on the history each one of the transactions, and it shows here as well one file extra in the dataset. So once we build, only the new transactions are actually going to be processed. So you can see here that the first three rows still have the old process timestamp, and the new row that is from the new transaction was already processed at 1 p.m. 3 minutes, which is this row here selected. So let's now invalidate a transaction. In this case, let's re-upload a file that already existed, transactions.scv, which are the first three rows. We can delete the rows, just upload them, again, go through the process, generate a new update transaction, import and validate. Like, there are a million ways of ingesting data into Foundry. We'll cover that in other videos. So here you can see, like, because we've rebuilt, we invalidated the transaction that already existed, it forced the incremental pipeline to recompute everything. You can now see that the process timestamp, all of them have the same time, which is 1 p.m. 6 minutes. So let's add some more data. to show some edge cases within incrementality. Here we're adding a new row. I accidentally skipped ID number 4, but it's okay, it doesn't really matter. We add the file called transactions3. We're going to drag into it. Again, we're going to generate a new append transaction, which just adds an extra file. We can confirm that within both the history and within the details. The row itself doesn't show up in order, but that's because when rendering a preview, it just randomly loads the files. So the order within the files is going to be retained, order outside of the files it isn't, but that's fine. Here you can see that only the new row actually got recomputed. If you keep reheating build here, you're just going to end up getting always at the same timestamp because the data is not getting recomputed again. We can also see this by adding a new column or some new logic and hitting rebuild. Because all the data had already been computed, the new logic is not going to be applied to any of the rows that had already been computed. However, if you keep ingesting data, for example here, we're going to add another row of data, now transactions 4. This new data will already run the whole code and will already get that new row that we added in PySpark. Here again, you can see that it's another append transaction. The file is there now, has transactions 4. So if we hit build, the column foobar that is going to continue being null to all the other columns now is present in this new row of data that we just updated, as you can see here. Now, what about if I want to actually recompute it in all the other data? So in this case, you need to recompute your whole data set, meaning that you need to bump the incrementality and say, let's do a build that is not incremental for once. To do that, we actually have a parameter in the incremental that we call semantic version that tracks when was the last time that your whole code ran. Bumping semantic version, which defaults to 1, will force your whole pipeline to be recomputed, or in this case, your whole dataset is going to be recomputed, and that new column that we just added is going to now show present in all the transactions, as you can see here after the build finishes. So that's pretty much a taster of incrementality. There are some other parameters that you can explore in the documentation, namely to verify if inputs are incremental and to play around with some more advanced things. We may cover those in future videos. So for now, thank you for listening in and see you in the next video.